Today we're going to be looking at shapes of distributions. So what does that mean? If you have some data and you graph that data, what does the data look like on the graph? All right, so to get started, here are the state standards. And one of the key ideas is if it's skewed to the left, you can see here that this is, they call this the tail, and it is skewed to the left hand side, and you can see more of the data points go here on the right. Symmetric means it's kind of uniform, which means there's kind of an equal distribution on the left and the right. That's called symmetric or symmetry. And then skewed to the right, you can see this long tail that extends out on the right hand side. So more of the data is on the left. That means it's skewed on the right hand side. If it's uniform, it will be pretty level. So you can see that all the data is pretty much the same across the board. That's called a uniform distribution. So these are different shapes that we will see, and that's important to know. All right, another key idea is being able to choose the appropriate measure. All right, so the mean, hopefully in years past you have studied the mean. The mean is the average. So if you take all the numbers, you add them up and divide by however many numbers you have, that's how you get the mean. All right, so you have a mean and a median. The median, remember, is the middle number. If you put the numbers in order from least to greatest, and the middle number would be the mean. And then the mode shows up the most often. That's not on this picture here, but you will see that in some of the stuff that we look at today. All right, to be successful, you need to be able to describe the shape of the distribution. Again, is it skewed? Is it symmetric? Is it uniform? You need to be able to determine which measure of center or variation best represents the data. And you need to be able to compare data sets. Example 1, describing the shape of a distribution. The frequency table shows the number of raffle tickets sold by students in your grade. Display the data in a histogram. Describe the shape of the distribution. All right, so if we look at the table here, okay, we have number of tickets sold and we have frequency. So we can think about this as our X and this is our Y. So if we want to display the data in a histogram, that means we're going to graph this information on a table, so a histogram table. All right, so we are going to put this as our x-axis. Remember, our x-axis is the horizontal axis. And since each one of these is a range of numbers, that means that's going to represent the first bar. This will represent the second bar, the third bar, etc. And then the frequency, this will be the numbers on the left-hand side, on the y-axis. So I have a graph here I'm going to show you. I can graph it, but if I do, it's not going to look as pretty as the one I have here. So let me see. I have copied this so that I can put it on here and it looks all nice and neat. All right, so again, you can see the x-axis here. Here's the x-axis, so those number of tickets sold will go along the horizontal axis or the x-axis, like I said. And then the frequency, the y values, and since these go from 0 to 25, you can see they went by a scale of 5. So as long as this goes by even numbers, if it jumps up by even numbers, you can go by 1s, 2s, 5s, 10s, whatever you need to go by. But they went by 5s in this case. All right, and then you can see that from 1 to 8, number of tickets sold, the frequency was 5. So that's how you make the bar graph there. And then from 9 to 16, the frequency is 9, which would be just below 10. And then from 17 to 24, there are 16, so it would be just above 15. And you can see how that graph is formed from that table. All right, so it says display the data in a histogram. So here's your histogram. And then it says describe the shape of the distribution. Well, if you look at this distribution based on what we looked at in the key ideas, this to me looks kind of like a uniform shape. This one's just a little bit lower, but overall it's kind of the biggest is in the middle and it kind of goes up and back down, kind of shows symmetry. So I would say, since each dot is kind of a mirror image of each other, that this would be considered asymmetric. So the distribution would be symmetric. All right, so the distribution would be considered symmetric. Example 2, choosing appropriate measures. You measure the speeds in miles per hour of 30 motorists. The results are shown in the table at the right. Display the data in a histogram using 6 intervals beginning with 31 through 35. Which measures of center and variation best represent the data? All right, so you can see in the table here, they give you the 30 speeds. So the first thing we need to do is make a frequency table, and it's telling us what the intervals should be. So the intervals are going by fives, and it starts 31 through 35. So then 36 through 40, etc. And then you just have to count how many different speeds are going to show up in each interval, and that would be considered the frequency. So let's pause the video, go ahead and make a frequency table, and then we can make a histogram from that frequency table. All right, so we can go ahead and list our intervals. We know this is going to be our x-axis, and our intervals are going to start with 31 to 35, 36 to 40, 41 to 45, 46 to 50, 51 to 55, and 56 to 60. All right, once we have our speed intervals listed, then we just have to count up how many in each one of these will occur for that frequency. So the frequency is how many times it occurs, how many times the speed occurs during this interval here. So if we look over here from 31 to 35, there is just this one. All right, 36 to 40, so we have 1, 2, 3. All right, and then what I want you to do is just pause the video and go ahead and count how many times this occurs for each of these next 4 intervals. So we're going to finish the table so that we can draw a histogram from the table. All right, if you pause the video and took time to do this, hopefully you got 5, 6, 11, and 4. What you can do to make sure that you have the 30 motorists all accounted for, let's count these up. 4 and 11 is 15, plus 6 is 21, plus 5 is 26, 26 plus 3 is 29, plus 1 is 30. So these numbers here totaled up should be a total of 30 motorists. That's all the numbers here in the table. So we can feel good that we didn't miss anything. All right, now take this table and we're going to make a histogram from that. All right, once again, I'm going to cheat a little bit and copy the histogram from the book because their graphs are so much nicer than the ones that I would make. So you can see the x-axis, that's your speed in miles per hour here. You can see on the left-hand side your frequency again. This is your y values. So you know that this is going to be your x-axis and this is going to be your y-axis. And then in that interval here from 31 to 35, there was only one time that occurred. So here on the frequency, this frequency table, they went by 2s. So 1 would be halfway between 0 and 2. And then from 36 to 40 was 3. So that would be halfway between 2 and 4. So you can see how they got that graph here. So each of those numbers, and you can see 51 to 55, that's your largest number there. That would be up to 11, and that would be between 10 and 12. So again, these numbers are evenly spaced. These are evenly spaced too, but these are the intervals that were given to us in example A, and that makes your histogram. All right, so example A, display the histogram in the display the data in a histogram using 6 intervals beginning with 31 through 35. Okay, so that's this table here. Sorry, this table combined with this is the histogram. All right, B part, which measures of center and variation best represent the data? All right, so because most of the data is on the right, this means that this is a tail here on the right. So remember in the information that we were given in our notes, this is considered a tail on the graph. So that means that it's skewed to the left. Since the tail is on the left, it's skewed to the left. So since it's skewed to the left, that means probably your median would be the best bet. The average is going to be off because more data is in the higher numbers here. So your data is going to be off if you consider your average. And the mode is the one that shows up the most often. And again, that's like to the far left here. So I would say the median is going to describe your data the best. Remember, the median is if you list all of these in order from smallest to largest and you choose your middle number. That would be the median, and that would probably dictate the middle of this data. Not dictate, but that would represent the middle of this data the best. All right, so median would be the best. All right, that's all for example 2.